Welcome to Fun with Science. My name is Mr. Ross, and today we're going to do a little further study on how to generate some electricity. I have two electrical engineers with me today,
Caitlin.
Melissa.
Caitlin and Melissa. The last show we did some static electricity. You remember that program that we put together with static electricity?
Yeah.
Static electricity, how did we get that generated?
You run the cloth over the balloons, and it makes the negative and the positive
Charges, right.
charges.
If you remember, the balloon became negative charged, and what is the
Positive
Positive.
charge.
positive charge? Why?
Because
You're rubbing them
you're
off.
rubbing them together and
We're
you're
rubbing
rubbing them
them-
off.
What are we rubbing off?
The positive charges onto the cloth.
Right, okay. So, we also talked about, what we're doing is we're moving electrons, right? We're moving electrons from the piece of wool into the balloon, right? So those electrons are charged negative. So if we get an excess of electrons on the balloon, it becomes negative charge. We take the electrons away from the wool, and it becomes positive charge, right? Right. So what we're going to do today, that's a pretty difficult way to generate electricity, even though that happens every day when we walk across the floor and so forth. But it doesn't power the lights in here, right? It doesn't make your stove work. It doesn't make your refrigerator work. It won't start your car in the morning, all those other things. So we have to have some other ways to generate electricity. What's this?
A battery.
Battery.
That's a battery. What's this?
A
Lemon.
lemon.
Lemon. All right, you got 50% right. This is not a battery. It's really, what's the name of it?
Duracell.
Does it say Dura battery on it?
No.
It says Duracell, right? This is a cell. Technically, this is a cell. It's not too bad because everybody calls this a battery. I call it a battery, right? But really, it's technically it's a cell. It's a single cell. This, you said, was what?
A lemon.
A lemon.
It's a lemon. You sure?
Yeah.
Yeah.
You sure it's not a cell also?
I'm not sure.
I'm not
Okay, well, we're
sure.
going to find out, right? Just remember, this is a cell, this is a lemon, right? Now, when we do electricity, we need to measure some things. We got to be able to tell that it's there, right? And there are several different kinds of measurements we can make to measure electricity. One, I got the right chart up. One is amperes, right? And I know you haven't heard that term before, have you?
No.
Right. Electricity is the flow of electrons, the movement of electrons from one place to another, right? Like through a piece of wire. The electrons are coming in to light these lights, right? They're coming from a power plant, probably up at Seabrook, comes down a wire, comes in, powers the lights, and those electrons then go back the wire, back to the Seabrook power plant. They make a big, complete circuit like that. Right. How many electrons go past a point in a given time is the amount of current that's flowing, right? And we measure that in amperes, right? Now, to get those electrons to move, how are we going to get them to move? You're standing still, I reach over and I push you, what? I put a force to you to make you move, right? So we have to have a force to make the electrons move too, right? And that force is called voltage. All right? Now then, you try to make me move.
You can't.
I didn't move. Why?
Because you're stronger than me.
Because I had some resistance. I resisted you pushing on me. Push me again. Right? Now this time I didn't resist, right? So I was able to move. Do it again. Right? So there's some resistance. Now, if we're going to take a look at, we have to measure those, take a look at electricity, we have to measure those three things. The ampere, how many amps or how many electrons are moving past a given point, right? The voltage, the thing is pushing them, right? And we also have to measure the resistance. Okay, so I have a meter over here. This meter is called a multimeter because it measures all those things, right? It measures voltage, the force that's pushing, right? It measures the resistance, and it measures the current. And we can turn it on And it's digital when it comes up. Right now, it should be reading pretty close to 0. Just 0, 0, 0, 0. Now, you said this was a what?
Yeah.
Yep.
It's a lemon?
Yeah.
You sure?
Yeah. No,
Right.
but yeah.
What if I take, right, I hook some wires up to my lemon. Right? I got my lemon and I have 2 wires hooked to it.
No, you don't want to eat it.
No, I don't want to eat it. I don't like lemons anyway. Come around here for a second. All right, meter is reading. It's reading voltage now, and it's reading 0, 0, 0, 0 because there's no voltage. What if I hook it up to my lemon?
It has voltage.
What does it read?
Neg.
It's a negative
Negative.
0.399.
9,
9.
4.
So it's about 0.4
4.
volts, right? So what does this become now?
A cell.
It's a lemon and it's doing 0.4 volts, right? What's this one?
A cell.
It's a cell,
A cell.
all right? And what's it read?
1.5.
592.
1.55, 1.592,
592,
right?
yeah.
About 1.5, 1.6 volts, rounded off. And this thing here also generates some voltage.
But it's negative.
It's negative. What if I turn it around?
It's positive.
Positive.
It's positive. So if I took my battery now, let's go back and look at it in a minute. I can do this and this. What is it?
Positive.
All right, let me connect the wires up the other way.
Negative.
Negative, right? So the meter knows actually which way. This is the positive terminal on the battery, right? This is the negative terminal on the cell, I'm sorry. Negative terminal on the cell, right? And if I hook it up, my meter up right, I get a positive reading.
If you hook it
And
up
if
wrong.
I turn it around,
You get a negative.
Yeah.
I get a
Negative.
negative reading. All right. So, what's this?
A cell.
It's a cell? You sure this is a cell now?
Yeah.
Yeah.
No, this is a battery. All right. Let's see if this is a good battery. This one's, the battery isn't good. All right. How many volts should be getting out of this battery?
A lot.
This one?
Or maybe
don't know.
not a lot.
This is 9 volts, right?
So,
Okay. So this is 9 volts. Now, how are we generating electricity with this lemon, the batteries, or the cells? How do they generate electricity?
I don't know.
Okay. The way they do that is if we take a look at the lemon. This lemon has on the inside of it what? Some acid, right? And what I have is that little strip, which is copper. Right, I put it in there. And this strip here, is that copper? Does that look like copper?
No.
It looks like something different, right? It's a different metal, right? So if I take copper and 2 different metals and I put them in there, and the acid inside the battery, inside the cell, right, is going to do a chemical reaction which causes one lead to become positive and the other lead to become negative. It generates a voltage, which is going, if we were to hook this up to something, it's going to generate some electricity. Okay? Like this. This is a 2-potato clock. Right?
2 potato clock.
It's a 2-potato clock, right? 'Cause it's got one well here, one well here. And originally, this was used, right? They put potatoes in here, right? The only thing is that after it sits around for a while and the potatoes start to rot, they don't smell very good. So I prefer to have lemons. Okay, and what we're going to do is I'm going to hook up two lemons in here. It's going to become a 2-lemon clock. And what happened? It came on, right?
Take it on.
Right, we don't have it set, but it did come on. So now then, I have 1 lemon here and 1 lemon here, right? And they're generating electricity, which runs my clock. So if you have an electric clock at home,
Yeah.
you can take 2 lemons and make it run, right? So we have those two lemons. Now, this 9-volt battery, this 1.5-volt cell, both do basically the same way, right? This is electricity generated by the chemistry, the acid acting on those 2 metals, right? And in here, we have an outside metal, right, on the outside case. The inside is a different metal, right? So this the positive terminal up here, negative terminal down here, are 2 different metals, and then between them, we have some chemicals, right? And that chemical reaction generates electricity. In this particular case, it generates 1.5 volts of electricity. We only had about 0.4 of a volt of electricity coming out of the lemon. And the reason for that is the metals are basically the same in this cell and the lemon, but the chemical on the inside, the acid, right, is much stronger, right? So that it's able to generate more voltage. No. How much voltage does that one cell create?
9.
This one?
That was 1.5.
1.5.
9.
1.5, right? So if I take some batteries, some cells, how many have I got?
1, 2, 3,
4, 5,
You got
6.
5?
6.
6.
6. 6 cells, right?
Yeah.
And each one generates how much?
1.5.
1.5.
What's 6 times 1.5?
6 times 1.5.
9.
9. Right. 6 times 1.5 is 9. Very good. Right. What I'm going to do is I'm going to take them and I'm going to put this one in here like this, and we'll put them in all in the same direction. All right. So that they're all hooked together in the same direction, and the only reason they're in the tube is because it's hard to hold all 6 of them together. Now come around here in a moment. So we have, how many cells do we have in here?
6.
6, and they're all in the same direction, right?
Yep.
So each cell has how many volts?
1.5.
1.5, and 6 of them should have what?
9.
9. Let's see. So what I'm going to do is I'm going to take the meter, and this is the negative side of my cell. And what do we have?
9.71.
9.71, a little bit more than 9, right?
Yeah.
So all 6 of those cells added up to be 9.71.
0.71.
Right, and if we take this little cell or this little battery, and how many does it have? It has almost 9 also. It's 8.5. Right? So now, 6 of these cells,
Has
9.
9.71.
This one, if it was fully charged, would be 9.5 also. So how many cells do you think are in there?
9.
9. Each cell generates about 1.5 volts. So there are 9 cells in there. Just to show you what I did is I took one of those apart. Okay? Here's what it looks like on the outside. Took the cover off, and it looks like this. Here are the little terminals up there. And there's 1, 2, 3, 4, 5, 6 little cells. Each one of those little cells gives me what?
1.
1.5. 6 of them gives me a total of 9. So this little 9-volt battery that you use in your transistor radio is really 6 cells. Now, car batteries have 12 volts. How many cells do you think they have in them?
A lot.
12 volts? A lot? Right, each cell in the car battery, all right, because it's got, the more nasty the chemicals that you have, right, the stronger the acids and the nastier the metals are, the more voltage it puts out, right? And the car battery is a lead acid battery. Both of those materials are pretty nasty materials, right? So each cell in a car battery puts out 2 volts. So a normal car battery is 12 volts, so how many cells would be in it?
8.
No.
2 into 12 is
6.
6. So each one has 6. Now, you know what this is?
A battery.
It's a battery, right? It's not a cell, right? This is a battery because it puts out 6 volts. And this come out of Power Wheels, you know, the little cars?
Yeah.
Okay. Now, so it's 6 volts. It's a lead acid battery. Right? It's got cells in it made out of lead and with acid in them. So how many cells are in this one? Each cell puts out 2 volts, and
3.
there would be 3 in this one, right? Because it only puts out half the voltage of the car battery. This is 6 volts. Now, what happens to this battery when it runs down?
You have to, it don't work.
It don't work. What do we have to do to it?
Charge it.
We have to charge it, right? What happens to this battery when it runs down?
You gotta buy a new one.
You got to buy it. You throw this one away and buy a new one, right? So they're a little bit different, right? This is a rechargeable battery, right? This lead acid battery, and this is not a rechargeable, right? This is called a primary cell, just for your information, and this is called a secondary cell, right? So this is a rechargeable. This one is not rechargeable. Right. So all of this generates electricity by
Lemons.
right, which is the chemistry, right?
Yeah.
This is lead acid, which is chemistry, chemical. The static electricity we got was actually chemical, right? So we can use chemistry to generate some electricity, right? Now, we got any other way to generate electricity? Can you think of any other way, maybe? What about the windmills, right? Big news today is the windmills that they want to put out off the coast and let the wind generate electricity, right? You ever seen anything on TV about that? Right. This is
Magnet.
a magnet, right? So, what I'm going to do, I'm going to hook my meter up like this, right? The meter is there, and is it reading anything?
No.
What happens if I go like this?
It
It went
goes up.
It goes up, right? It read a little bit, right? If I move it up, down, up, down, up, down. What am I doing? I just generated some electricity, didn't I? So what my meter told me. It said, I'm not generating very much, but I'm generating a little bit, right? Up, down, up, down. What happens when I go up?
It goes.
It's a
the number
positive,
goes up.
right?
Yeah.
When I go down, what is it?
And
Goes to a
negative.
negative.
So, the direction that the wire is moving in between, there's 2 magnets here, all right, with the magnetic lines of force going across this way. So as I go up, it's positive. As I go down, it's negative.
negative.
So the direction that it's going determines what polarity I have, right? And how fast it's going determines how much voltage. If I take the movement very slow, right, I don't get much voltage.
It stays the
Right.
same.
Yeah.
If I move it faster,
You
Right.
get more.
You get more.
I get more voltage, right? So the faster I move it, the more voltage. If I were to take and loop some wires around in there, right, put more turns, put more wires through here, loop this thing around a little bit, let's see if we can get a couple more volts out of it. Like this, right? And what happened to the numbers?
It goes up higher.
It goes up, right, because there's
2.
two now instead of just the one, so it's more voltage generated. Now, for me to sit here and go like this all day long and generate electricity, I'm going to get tired before too long, right?
Yeah.
So what I need to do is I need to find a better way of using that. Take these wires out. I have a better way. Let's try. Piece of wood. Set my battery down on top of it. Bring my magnet. What's this?
A stick with wire.
It's a stick with wire, right? Right. I have several turns of wire on there. I don't know how many there are, probably about 10. Okay, and they're connected up here to these little contacts, right? Right, because what I'm going to do is I'm going to take this and I'm going to set it in here like that. All right?
It's already sending.
Yeah, a negative charge. No.
That's because we're magic. Now, I'm going to hook this up like this.
You're getting a voltage.
I'm getting a voltage out of it, right?
Yeah. The faster you go, the more
The
higher.
faster I go, the higher it goes, right? And if I go,
It goes negative, the
go
opposite.
if I go in the opposite direction, it goes negative. So what I've got, I got several loops of wire there, all right? And I can turn them pretty fast by rotating this shaft, all right? The stick, and I can generate electricity. But I'm gonna get tired twisting that thing. What if I do this?
And spin it.
Yeah, I think I take it outside, let it sit there, and let the air blow across it. What's going to happen? It's going to spin, right? We have to make contact here. It's going to spin, and I'm generating, generating electricity using what?
Air.
The wind. Now, how does the nuclear power plant work?
By wind?
No, but it's a good answer. It's almost right. What they do in a nuclear power plant is they take the nuclear energy and they take water. And what they're doing is boiling the water and create steam, which then they let that steam blow across a propeller, which is called a turbine, something like this, right? And it in turn drives a shaft with that big loop of wire on it, which is sitting in there, and that's what generates the electricity. If I have, some of the power plants are powered by, they use coal or gas, some of the fossil fuels, right? And they do the same thing. They heat up water, which then that water turns to steam, goes across the turbine, right? And causes the turbine to turn, right? Which generates more electricity.
It's generating like electricity
Yeah.
without moving.
That's just because of the static electricity in the air. Right? If we were to take them, put them together, right?
It says
Zero.
Yeah, it's just the reason it's jumping up and down is because of the static electricity that's in the air on the wires. Right, now, so, all the power, the wind power that we see, the nuclear power, the gas power, gas-fired power plants, the coal-fired power plants, right? They also have some power generating things with the waterfalls, right? Like over here at the dam, there's a little power generator at the Great Dam, right? And what it's doing is the water's coming over the dam, going through a turbine, which is cranking, turning some wire in a magnetic field, right? And generating some electricity. Right, so the big dams, right, what they do is the water comes down, goes through that turbine, and turns this big loop of wire that they have in a big magnet and generates our electricity. So that's another way of generating electricity. You like that one?
Yeah.
Okay. We got some other way? Yep, let's try it. Now, that we didn't generate much electricity with that, but what we have here is a little generator, right, which is just like this. Here's the shaft coming out the front, right, and connected on that shaft is a loop of wire, just like what we have there. There's some magnets in here. So if I turn this, what I'm doing is I'm turning the loops of wire through that magnetic field, and I should be able to generate some electricity. Right, I have it connected up to a light bulb. Hold that, hold that. I'm going to become a nuclear power plant here. I'm going to wrap some string around this. All right, what I want you to do is I want you to hold that pretty tight, so that, because I'm going to pull on the string and I don't want it to get away. All right, and we're going to watch the light bulb. Oof. You didn't hold on to it tight enough. I said tight.
Okay.
Tight, tight, tight. Yes. All right, what I'm going to do is I'm going to let you pull the string. I'll hold the generator, right?
Just pull it.
Just pull it as hard as you can. What happened?
It went on.
It went on, right? You want to try it again?
Okay.
Now that we know what I'm going to do. All right. Come on. All right, so same principle as this. All right. Now, do we have any other way of generating electricity?
Fire?
Hmm?
Can you use fire?
Use fire? Well, we're using fire to heat up the water to make the steam, right? To turn this turbine, which turns the generator here, right? So we can use that. Huh. I have a little calculator. You're all familiar with the calculator,
Yeah.
right? And your calculators, a lot of them what?
They work
They work, yeah, but why do they work?
because of the stuff inside.
Because but what powers them? So, some of them have batteries in them. Okay, this particular one has something called a photocell up here
With the light?
with the light. So that as long as the light's shining on it, this provides power for
The calculator to
the
work.
calculator, right? So we can take with this photocell, the photoelectric cell, and we can generate electricity by shining light on it. Cover it up,
It just doesn't work.
it doesn't work, right? So you can't work your calculator at night in the dark, right, with this. Okay. So photoelectric, so the light shining down upon it, right, is going to generate a little bit of voltage. Now, I have the half here. Guess what that is?
The thing in the disc?
That's the same thing as in the calculator, right? Right? And this is a big photoelectric cell. This photoelectric cell, right, what its purpose is to charge car battery. Right? So, in order to charge the car battery, it's going to have to put out about 12 volts. Right? Hold that. Don't go away. I'm going to go down here and I'm going to hook it up to my meter. Now, if you smile at that, right, it's probably going to generate more than 12 volts because of your bright, shiny face. You want to hammer around over here and look, see what it's generating? What is it?
A lot.
14.
14.37, 14.4 volts. That's because she's smiling, right? If she were to frown, right, it wouldn't be so bright in here and it wouldn't generate as much electricity, right? What happens if I cover it up?
It's going down.
It's going down, right?
It's going back up.
Go back up about 14 point, almost 15 volts, right?
15.
That's because she smiled, right? Any other way we can generate electricity? Hmm?
Wires, maybe?
Wires? All right.
There's one on the
Another way is a thing called thermocouple. Now I put this one together, right? So maybe we can see it on the camera. What it is I have a piece of coat hanger, which is iron, and I have some copper wrapped around it, right on this end, and over here I have some copper wrapped around here. Now, so I have two different kinds of metals, right? And this is called a thermocouple, right? And it generates electricity, not much, just a little bit, if I take and heat one of these. These two, where these joint where the dissimilar metals are, right? And I heat one, it's going to generate a little electricity. Now this one, right, is just for the camera because it's a little bit too big. So I have another one down here, which nobody's going to be able to see except us, right? Right? And this one should work. So what we're going to do is we're going to go around here again. And I'm going to disconnect from my battery, right? And we're going to hook my meter up to this again. This. And like this. Now, so I'm going to heat one of these. Now, watch the. What's it doing?
It's sending voltage.
Sending voltage, right? My meter read 0.002,
And it's
Well,
still there.
and it's still there because this is still hot, right? Now, that doesn't generate much voltage, but it does generate some voltage. And what this primarily is used for in a lot of places is to measure temperature, because the hotter we make it, the more voltage it's going to generate. So if we were to have something real hot we wanted to measure the temperature on, right, we could put this thermocouple in there, right, and it takes two joints. It takes this one and this one, right, and we heat one of them up, and we can measure the temperature then. We can measure the voltage, and that can tell us how much the temperature is, right? So that's called a thermocouple. Right? Any other way you can generate electricity?
Fire?
Something to do with it.
Something to do with this? That's a good answer. Something to do with this. No, it's not the fire, right? It's the thing that starts the fire.
It's like a shock or something.
There's like a little shock or something. All right, where does the little shock come from?
When you
And
push it
when
down.
you push it down, it rubs against something, and it causes.
Well, there's a little piece of wire in here that's broken, and right, there's a little spark that jumps across there, right, which is what lights the gas, right? But what causes the spark is a little bit of electricity, right? And the way we generate electricity, listen to it,
The snap.
the snap, right? The snap, what it is like a little hammer, and that little hammer hits a crystal, right, in there. And when some crystals, like the quartz crystal, if you hit them, right, they generate some electricity, right? In this particular case, it's probably a quartz crystal in there, and we hit it, and it generates electricity enough to cause that spark, right? And light this off. That's called, pay attention to this one, right? It's called piezoelectric effect,
Piezoelectric
Piezoelectrical.
effect.
Piezoelectric effect, right.
Piezoelectric effect.
So, where else could we possibly find that? I mean, obviously, this lighter, but
And other kinds of lighters.
and other kinds of lighters.
And other kinds of stuff that snap. In your watch.
My watch, what's it say on my watch up there?
The date.
No.
Oh. Time.
What's the word right underneath the name? It's a cheap watch, but what's the name, word's the word right underneath? Quartz. Quartz, right? And so what it has a little quartz crystal in there, just like this. All right?
That makes
Which
it move.
There's a little thing that hammers on it, right? And it causes it to generate electricity, which keeps the time. It's sort of like a pacemaker, right? You know, the pacemaker they put in your heart to make your heart beat at the right time, all right? Well, that's what this is a pacemaker for the watch to make it, you know, beat at the right time, so it keeps the correct time. So that's quartz crystal. Now, so we've got several ways to generate electricity. One, which is chemical, right, which was we did with our lemons, this lead acid battery, right, these little cells, right, or as everybody calls them batteries anyway, but they're really cells, right? What did we do with the other one? This one here, this is what? This is a,
Battery.
that's a battery because it has
Little battery.
it has little cells.
little
It has 6
cells.
cells in it to make it up, right? This was, when we put all these together, all these 6 cells in here, this is a what?
Cells.
What is it? After we put the 6 cells together.
A
Once,
battery.
this is a cell. We put 6 of them together, we
A
get
battery.
a battery. And this put out 6 cells was what?
15.
9 volts, right?
volts. Yeah.
And this is battery.
3. Oh, that's a
Battery.
battery.
Right. It's a 6-volt battery, and it's lead acid, so it has 6 cells in it. Or 3 cells, I'm sorry. The car battery is 12 volts, which has
6.
6. All right, so those are all chemical. The static electricity thing was chemical also. Right? This is called electromagnetic source for electricity, and what we're doing is we're moving a conductor, a piece of wire, through a magnetic field. So all of our power plants that we have right now are
Using that.
using that. Right? That over there, this one here, this
Is
big
the
one.
sun.
We're using the light. It doesn't have to be sunlight. It just has to be visible light. Because we don't have any sunlight in here today, except for your smiley face. Right? This is photoelectric. Right? And this one is a thermocouple.
Yeah.
Right? And what we're doing is we heat 2 different metals, joint where the metals are tied together, and it generates a little electricity. And this one was called what?
That
That
the long
cart
name.
quartz.
It has P.
It's quartz. That has quartz crystal in it. What's the effect? Piezoelectric, like
Yeah.
pizza.
Piezo.
Piezoelectric, right? Piezoelectric. And it's the same quartz crystals in my watch. All right, so I think that's it for today. We've had enough electricity. Right, so you're going to remember now. We've got 4 ways of generating electricity. One is with chemical reaction. One is with magnetic field, right? And the wire moving through the magnetic field. We have piezoelectric, and then we have the photoelectric, the photocell, which we can use to charge my car battery, powers our calculators, and all kinds of other gadgets we have. That's it for today. Thank you for watching.